In this video, I want to make some clarifications, some very important clarifications related to node referencing and node assignments. So this material that we're going to talk about right now is really critical, and it's the most common source of errors that I find and that I see when students are learning how to deal with nodes. So I want to make very sure that everything we're going to talk about in these next couple minutes is very clear, and post any questions about it to the discussion board. Do lots of practice with this idea on your own to make sure you understand these distinctions that I'm going to be talking about. So when we traverse a chain of nodes, we use a temporary node to point to each node in the chain, right? We've seen that you can use current node or node before or last node, whatever it is. Use a temporary node, and you start it at first node, and then you advance it forward with the dot next, dot next, dot next until you reach whatever node you're trying to reach, or traverse the whole list, or whatever you're trying to do. So this line of code where we declare and instantiate that current node, this creates an alias between current node and first node. That means that they point to the same place in memory. They point to the exact same node object. So you have one node object and you have two different references pointing to that same object. So keep that in mind. And what's really important here is to understand the difference between reassigning that current node to a new reference, a new node, and to making changes to the actual contents of that node. So if we just talk about reassigning the current node, what we're doing is we're just making that current node reference or current node variable point to some other node. And what that looks like is this. We have some node on the right-hand side and current node on the left-hand side. Now, this might be a single node variable like first node or last node, or some other node named node variable, but it also might be a dot next, right? It might be some node dot next, because remember that dot next also, the type of a dot next is a node, right? Dot next points to a node. So this is going to be some memory address of some node on the right hand side. When the statement looks like this, what you're doing is you're reassigning current node to point to some other node. This will break that alias between current node and the first node, what you initialized current node to, and it means that current node points to a different place in memory, some other node. But what's really important is that first node has not been changed by this. First node hasn't changed at all. It's no longer an alias with current node, but the actual node of first node hasn't changed. So what this means is that the entire structure of the linked chain, which of course we know we access, it's headed by first node, hasn't changed. So just reassigning current node does not change the structure of your chain, right? So if this looks like this, let's say current node first pointed to first node, so current node pointed here, and then let's say we updated it so that current node pointed to current node dot next, so current node dot next is this node here, so now current node points to this node here. We've advanced current node. We've said current node gets current node dot next, but notice that we haven't changed the chain at all. The chain has stayed the same. First node points to the same node. Each node internally points to the same next node, and then the last one points to null. The chain of nodes hasn't changed at all. So reassigning current node doesn't change the chain. And this is the correct way to iterate a chain, right? We advance through, making the current node point to something new, but no changes are made to the chain. And again, what this looks like when you're reassigning current node is it'll be some node reference on the right. So either a named node or some node dot next or something like that with current node on the left. When you see this setup with basically current node or whatever your temporary node variable is and a node on the right, so node variable equals node, you're just advancing the chain. You're just advancing through the chain. You're not changing the structure of the chain itself. Now, you can use current node to change the chain, but the code is going to look a little bit different. So let's again say that we start off with current node pointing to first node, so these are aliases. But now let's say we change something about the actual value of current node. Well, what are the instance data variables? What are the values, the characteristics of a node? They're a data or a next, right? So let's say we actually change something about the data value held inside current node. So let's say if the data is an integer, we said current node dot data is 14. Or let's say current node, the data is a student, we could say current node dot data dot set name and change it to some name. Now, if you do this, if you change something about the actual data value of current node, this will change the chain. Because right now, right, current node and first node are aliases. They point to the same place in memory. You're changing something about current node, so you're also changing something about first node because again, they point to the same object. So if again we had first node and current node pointed here, and then we said current node dot data dot set name is change, we'd go to current node dot data. Okay, well the data points to this object here, a student object, let's say, and then let's say we invoke set name to change. Okay, even when current node goes away, first node still points to this same node whose data points to this student here that has been changed. So we have changed the data of our chain through the reference to current node. And again, the reason that happens is because we're changing the actual values inside of current node, the actual data. Okay. Now this can happen if current node is an alias to any node in your chain. It doesn't have to just be first node. So if we had said current node gets current node, current node gets first node, then current gets current.next. So now current points to here. And then we change the data of this one. We'd go current node. Okay, get the data points here, change the name. And so we can do that as well. So if we are changing something about the data of the current node, that's going to change the data of the chain itself. Okay, this is sometimes what we want to do, right? This is how you can actually change something about nodes within a chain. You use that temporary node variable to advance to the position you want, and then you change something about the data by accessing current node.data. So you either assign it to some new data, or if it's an object, you might invoke like a setter method or some other method that changes the object. So this again is how you can change the chain, the actual data that we're trying to store in this chain. You can change it through the reference to current node. And what that's going to look like is it's going to look like a .data, current node .data, either on the left-hand side of an equal sign or the .data calling some method that changes the object. So this is what that's going to look like. Now there's one other thing that we might do while we're iterating through, and that's we might actually change the structure of the chain. So far we've talked about iterating without changing the chain. We've talked about iterating and changing the data stored in the chain, but we can also change the actual structure of the chain. So let's again say we start with our current pointing to first. Now let's say we actually change the .next of a current node. Well, this is again changing the data, changing the node. It's changing the node object itself. Okay, it's changing it by updating what its next points to. So if we were to do that after assigning it to first node, this would also change the .next of first node, again because they're aliases. This changes the actual structure of the chain. So for example, if we said that current node pointed to first node, so here first current node points here, and now let's say current node.next points to some other node. Okay, well current node goes here, same place first node goes, and now we're taking some other node, memory address of a node, and we're storing it in next. So this now points here. So we have changed the structure of the chain because when current node goes away, our first node is still going to point to this first node here, the Allison node, but then next now points over here to this some other node. This whole part of the chain has been removed. So we've changed the chain through access to current node. And we've done that again by changing the .next value of current node. And again, just like with changing the data, you could do this with current node pointing to any node. It doesn't have to just be the first node, right? If we just said current node gets first node and then current node gets current node.next, let's say this change had never happened. And now we say now current node.next gets some other node. Well, then it's going to say this is going to now point to here instead of here. Okay, so you can change the structure of your chain by changing the .next of current node. Okay, so this would be the resulting from that first code, that first example that we saw. So this is again how you change the structure of the chain. You advance the current reference to where you want to make the change, and then you make that change by altering the .next. So what this is going to look like is you're going to have the .next on the left-hand side and some node reference on the right. This might be a named node. It might be a node.next, because remember that a node.next is also a node. So there's just going to be some node on the right. So this is kind of a little summary here. It's really critical to understand these distinctions. This is, I would say, the key to being able to work with and modify nodes in your code. any node code relies on understanding these differences. Okay, and the differences are if you have some temporary variable on the left-hand side of an equal sign and some node reference on the right, this just changes what current node points to. It doesn't change the chain. If you have your node reference data with some other data on the right, or you could have your current node data some method, this changes the actual data contained in the chain. It doesn't change the node structure, doesn't change the order in which elements are linked together, but it does change the data stored inside those elements. Now, if you do current node next to some other node, this is going to change the actual structure. So this is going to insert a new node or remove a node. It's going to change the actual order of your chain of elements. Okay, so the distinction between these three is critically important. So it's important when you're evaluating code to always be thinking about, am I changing just the current reference? Am I changing the data in the chain? Am I changing the structure of the chain? And you can do that by always looking at kind of what's on the left-hand side. So when you're evaluating code, you can do that. But you also need to think about this when you're writing code. You need to be thinking about, what am I trying to do? Am I trying to change something about the chain, either the data or the structure, or not? Am I just trying to move through it? It just depends on what task you're trying to accomplish. So make sure that these ideas are really clear, because again, I would say this is the key thing to understanding how to work with nodes, is to make sure you understand this difference of what you're doing with the node reference. Are you just iterating through the chain, changing what that node reference points to? Are you actually changing something about the data contained in the node's elements? Or are you actually changing something about the node structure itself, the way that the items are linked together? So any questions about this, please post to the discussion board, because this is, again, an incredibly critical topic.